Okay, good morning, everybody. YouTube has spawned an incredible number of high-quality math sites, and I found this particular problem that really got its hooks in me at Dr. Penn, Michael Penn's website. He labeled it as something that came from a Nordic or Scandinavian math competition, and it really got its hooks in me because I'd never worked a problem like this, and there didn't seem to be any sensible standard approach to the problem. But I discovered one with his help, just watching his video over and over, and now I think I got it. So I want to share with you guys. So let's get away here from the cogitating couple. Now, you'll notice the way this problem is specified, the actual function itself is nowhere in sight. You can't see it in the usual y equals f of x Cartesian form. And you only have two clues on what the function does. It accepts a couple of inputs, divides by 3 is in condition A, and then, but you can see it's odd the way the function is defined. In fact, I debated, is it even a function? Maybe it sends a single value to two values, I don't know. But in any event, it turns out there's enough information given to evaluate it at particular numbers. Maybe every number, I don't know, I'm still exploring this. But anyway, the goal of this problem, given these two initial conditions, A and B, is to evaluate the function at 1/6. Now, and this is not like something I just noticed. I had to spend 2 or 3 hours on this, figure it out, but it says you repeatedly use these two conditions, so you'll get at least 2 occurrences of f at 1/6. All right, and then from that point, you can just solve for it. But that didn't even occur to me. You know, I was just willy-nilly trying all kinds of things. And it turns out all you have to do is use the conditions enough to get 2 occurrences of what you're looking for, the object you're looking for. All right, so I got started on this problem by applying condition A twice. Now you can take a look at this and verify f at 1/6, this uses condition A, right? From here to here, I hope you guys can see this okay. So f at 1/6 is equal to f at 5/6 divided by 3. Okay, now if you apply it again, it's the 5/6 that's getting placed in as x, and so you would get f at 25/6, but it's divided by 3 again, and so that you get f at 1/6 is equal to f at 25/6 divided by 9. Now you may ask, why did I apply it twice? And that was difficult too. I tried to work it by just applying it once, but notice that if you just stick to the f at 5/6/3 formulation, if you try to put 5/6 into condition B, you get f at -1/6, and the numbers just stay negative as far as I can tell, right? And we're not interested in evaluating this thing at a negative number. We want to evaluate it at the positive value 1/6. And so I applied it one more time. And now notice here, another key observation at this point is that 25/6 minus 4 is 1/6, right? 25/6 minus 4 is the same as 25 minus 24/6, which is 1/6, right? So that is essentially what condition B does. It subtracts 1 from the input, then adds 1 to it. And let me move down here, and I'll quit talking and just let you view it here. Whoops. All right, I'm trying to get this in viewing range for you all. Okay, you guys can see that okay, and the conditions are still on the screen. Now you can see right here, all I did was just recopy this back down here, okay? And this is a long string of equalities. But you can see, just like I was telling you, when you subtract 1 from 25/6 according to condition B, you get 19/6. When you subtract 1 from 19/6 by condition B, you get 13/6. You see, it's cool. It works all the way back down to f at 1/6. And so what happened is we got f at 1/6 on the extreme left-hand side, and we have f at 1/6 on the right-hand side of this long string of equalities, right? And so you can see at this point, f at 1/6 can be isolated and solved for. So that's the very next step here. And y'all can see what I did right here. I multiplied 9 times this to produce this term, and that's equal to this. Then when you subtract 1 of something from 9 of something, you get 8 of the something, right? Divide by 8 and you get f at 1/6 is equal to 1/2. Now, I just jumped when I finally figured out how to do these things, because I didn't really know, I just kind of watched what Dr. Penn did, and okay, he got the answer, okay, yeah. But really, it's just you repeatedly apply. And I'm not saying this is the only path to Rome. Some of y'all may be able to figure out to do it by just applying it 3 times. It turns out I had to apply condition A twice and condition B 4 times. Hope you guys enjoyed.